Hi, kids. Hey, I'm going to talk a little bit about diffraction and talk a little bit about Huygens principle. So, first, let's make sure I'll give you a scenario. So, let's say that there is a corner, and here is a person. We will call this person A, and then we have another person over here, and we will call that person B. Okay? Now, hopefully you know this, but if person A is holding a laser pointer, you know what? Person B is not going to see that laser, okay? Because you know what? That laser, when it hits this point, is, just pretty much going to go off in a straight line. It doesn't really bend at all. In fact, it doesn't bend at all. It goes straight. But if person A is talking, and they're sending out sound waves, so if I represent some sound waves going out, okay, if I have some sound waves going out, then you know what? Person B can still hear person A. And you want to know why? Because of this thing called diffraction. And here's where Huygens principle comes into play as well. That if you imagine that every point along here is a point source, and these waves went out, so like, hey, there's the wave going out, hey, there's, hard to draw waves going out, hey, there's waves going out. What I'm trying to show you is, hopefully you can see that these waves are all reaching the point at the same time, so that you're going to get constructive interference, and so you get this thing. Well, you know what? When you hit a barrier or a corner like this, that you can imagine there's a point source right here. And that point source, okay, that, again, there's a zillion point sources. That's what Huygens principle says. There's a zillion billion point sources here. And yes, these point sources over here will, cause the wave over there just to keep traveling straight, okay? And you'd get that sound wave keep traveling this way. But, and here's the part that's really cool, is the reason that person B can hear it, even if person B is right next to the building, is that there's a point source right there, and that point source right there is going to send out the waves. So those waves are going to go out, and because there's no other waves to constructively interfere with, well then you're going to get, so where here you just kind of get them going out here, but you get it so it actually bends around the corner. And so person B can hear it. And that bending around things is called diffraction. Why does it occur? Because if you think that every point along the wave is a point source, then you get this to occur. Then the second question is, well, why doesn't it happen with light? And it happens with sound because sound has a way bigger wavelength than light. And because this is a very big corner, in terms of, size of the waves, that which waves are going to diffract the best? Oh, that would be sound waves. Even, if you can talk about electromagnetic waves, radio waves have the longest wavelength. If you were to travel into Chicago, a lot of times if you're listening to an FM radio station, 93.1, WXRT, well, once you get into the buildings, you can't hear the radio station anymore. Why? Because FM has a higher frequency. It's 93.1 megahertz, 93.1 million waves per second. So that means that the waves are not going to bend very easily around the buildings. Where AM, if you're listening to an AM radio station, AM 1000, that's 1,000 kilohertz. So that's 1,000 waves every single second. They have way longer wavelengths, because again, if you think about our equation, this is the same, that if, bigger or smaller, then that's going to be reversed. Which is why if you're traveling into Chicago, you can still hear the AM radio stations. But hopefully that makes sense, especially with what you guys did yesterday as far as what is diffraction, what is Huygens principle, and bye, kids. Hello, Serena.